Hello everyone, as promised, here's the video on your input output of your lab 3. It's a very simple lab, as in the extra things you have to implement is very simplified in this document. So the output and the inputs you have to take care of extra is a very simple thing, although the algorithm may not be simple. So first, let's get that out of the way. What is the additional functionality you need to implement for this lab over your lab 2, which was your splits? You need to find the bounding face. So what I mean by bounding face, let's take this point P over here. And as you know, after you split, you get an extra face. So in this case, we had split, for example, this edge and this edge. It doesn't matter, but let's say this is the input that's given to us. Of course, we'd have vertices here and edge numbers, which is not included here. But the main point is, as you can see in this, there are two faces here. One is from here to here. As you can see, that goes clockwise, and another is from here to here, and that goes clockwise as well. Um, Now, a bounding face for a point in our definition is that the point that is contained inside that face. So over here, P, the bounding face for P would be 0, as in face index 0, and for Q it would be face index 1. Right, and now there could be some obvious discrepancies that come that, okay, what if it's here? What if the point P is over here? Or if the point P is over here? Well, we're not going to take care of such cases, although we can definitely define a convention for that. It's probably a lot more difficult to implement that. So every point that's given to you will be inside a unique face. So as in, it will not be on the edge, it will not be a boundary, it will not be a vertex as well. So it will always be inside. So all points will lie inside of a face. Actually, a unique face should be written here. Okay, so that is the extra thing you need to implement. What is the input format? The same as last time. So you have a list of points, your x and y coordinates, and then you have some split commands. So if you need a refresh on this, do see the previous video. You can definitely check out the playlist. And the third thing you'll implement is this part. So this would be in the same, like this would be appended to the same split commands. So that same file, and the format is id a capital I mind id hyphen a 1. So this is 1 2 or so on. So id hyphen number space x and then space y. So x and y are the coordinates. These are the new inputs. So for example, p, if let's say we took the first point as p, so its id would be 1 and this id would be 2, and the x coordinates for p and y coordinates for p would also be written there and over here. And you would have to find which face, or what is the face index of all of these points given by their IDs and their coordinates. So it's in the same file name of split command as mentioned earlier. So as you can see, it's pretty simple, right? At least abstract, if you speak in an abstract way, it's pretty simple that you only have an extra IDs here, and you just have to find out which faces these belong to. So the output format is the same as before. So you had your split outputs. You had mentioned some assumptions that you made in your README last time about which order you print the edges. But so the first part of your output is the same as last time. Remember, since this is a continuation of the last assignment, you will have splits as well. This is not a standalone thing. So after split outputs, this is the new part you have. So the format here is the same, pretty much the same as the input. So you have ID, capital I again, colon, your number, whatever that is, x, now space, your face index. So for example, in our case, it was 0 or 1 or whatever that is. So instead of x and y, you have to just give the face. And this will be in the same output file name as it did for the last time. So that's the only thing that you have to add in this assignment. You get a list of points given by their IDs and their coordinates, and you have to output the face index. So in this case, 0 or 1, but it doesn't matter. Now, some notes that you have to keep in mind. So the same conventions, rules, and guidelines as in lab 2. So that is for your split functions and so on. You have to follow the same thing, your rules and so on. And of course, the guidelines of including the README and all that is the same. Although after you perform the splits, if you follow the same guidelines, everyone should be getting the same output. So if you're just going to output in this format, you don't need any extra README for that alone. Anything in the README, sorry for that alone. So that's the first point. Every ID will always have unique bounding face, as I mentioned earlier. You do not have any points that is a vertex or that is on the edge or that is outside the figure. It'll all be inside. It'll have a unique bounding face. We'll make sure of that in all of our test cases. Mentioned all the subject README. Some of you haven't actually submitted a README last time, so it was quite a nightmare to look at your submissions, not because the code was bad, but because we couldn't understand what is going on. So please mention everything in your README. It's always a good practice as well. A second thing is you must have classes, header files, comments, outsourcing, constructors, and destructors. So these are some things that have been taught to you, and it's also good practice to include these things. Outsourcing as in outsourcing functions and stuff. you need header files and classes and comments. So as I mentioned earlier, you might have you can definitely go through the GitHub repo to see what kind of comments you need to put. And the fifth point is check all file names. So if your code doesn't compile, we really cannot give you marks even if it's a perfectly written code. So I do understand in the last minute if you have to change your file names or whatever to represent your roll number and so on. But do compile it once before submitting. And also as a general rule of thumb, make sure that your submission is ready at least an hour or so before the deadline. So I hope this clarifies all your doubts. If not, please ask us on LMS or via email. Thank you.